Professor Piata, how would you explain your project Imagine? Because it has a fantastic name.
Yes, the name is inspired by the desire to build robots that can imagine the effects of their actions. And in robotics research, and particularly in learning-based robotics research, we have been focusing on statistical models that the robots use to predict what they do. And we've had some remarkable success in the past, but to really interact with complex and structured environments, we need more. The robot has to have an understanding of the structure of the environment it's working with.
So you go away from statistical models?
No, we are going to keep statistical models in the picture, but we're going to complement them by physical models that we build into the robot's brain in the form of a physics simulator. And then the idea is to combine the statistical models and the physical simulation in order to equip the robot with a structural understanding of the world with which it interacts.
And this environment is dynamically changing, or what is your environment in your examples? Is it a home environment or outside? Or?
So at the back of my mind, I have home environments, a robot interacting with households, for example. But the use case of this project is specifically recycling of electromechanical devices. So the robot will have to dismantle electromechanical devices that come in different makes and models, but share some structure. So what we're going to develop is methods that allow the robot to understand this structure, develop an intuition for how to dismantle these items, and then autonomously dismantle devices of different types based on a structural understanding and the experience of the robot.
So what kind of applications do you think of? What is it to dismantle electronic garbage and for because like the old television set, or?
This is kind of examples we're looking at. One very concrete example motivating this research is old GSM amplifier boxes containing beryllium components, which are very hazardous to human health and environment. So they have to be dismantled by hand, which is a very costly process. And as a result, many of these devices are just shipped to Africa, where they pose enormous risks to health and environment. And we hope that by exploiting the structural understanding of the robot, we can automate this process to the point that it becomes economically viable.
Is your project looking for use cases or partners in commercializing this with the result?
Not yet, but 2 or 3 years down the road, this will become concrete because the payoff of the structural understanding will be relevant to a number of domains outside of recycling also.
Is there any message you have to the general audience about this project, or your desire to have more European end users for the results of this project, or what do you think? What would you say?
Yes, we believe that this level of structural understanding that we hope to equip robots with will step up the level of autonomy of robots and their capabilities of working in unstructured environments such as households or hospital scenarios, where they can contribute to quality of life by freeing our time to do more interesting things.
Okay, thank you very much, Professor Piata.